Morning, everybody. Just wanted to tell you that I'm going to be trying to do Monday, Wednesday, Friday videos, and then Tuesday, Thursday, I'm going to give small homework assignments. That way, we can be able to, not have every day having homework assignments or slash every day watching a video. It could be kind of one or the other. So today we're doing day 4 of chapter 23. I'm going to kind of put 2 days in one, but these are definitely going to be fine and quick, and we should get done as soon as we normally would. So chapter 23, day 4, we're now going to be talking about hypothesis testing for means. So the test that we're going to be doing is called a one sample t-test for the mean. On our calculator, it's just called a t-test. Okay, but we're going to call it a one sample, just like we would do a one proportion, one sample. Instead of a z-test, we're going to do a t-test. Okay, so we still have to look through all our assumptions and conditions. We still have to do a hypothesis. The hypothesis for the null is going to be the mu, the mean, the actual mean for the population, equals and whatever that number is. And the alternative is going to be mu equals or greater than, or doesn't equal or greater than or less than, whatever the mu hypothesis null is. Okay, so we have here in red the z critical value, how to calculate the z-score, and the z-score, t-score, excuse me, is going to be the degrees of freedom, right, n minus 1, and we're going to get the sample mean minus the population mean over the standard error. And degrees of freedom is going to be n minus 1. So let's do an example. This is still that cars driving too quickly on this one road. And if you recall from the previous one, they thought that the 30-mile-an-hour speed limit was being broken. And they want to know, does the mean speed of all cars exceed the posted speed limit? They don't have to give me anything else as far as giving me knowledge about what I have to do. If it's asking, does the mean exceed it, that would be, is there evidence that it's exceeding the speed limit? So let's go through what we need to. You should already, I'd like for you guys to follow along if you can. So you should already have the data in your calculator under stat edit. And let's just make sure that these are all the cars they looked at over a 15-minute period. If you recall, we felt like the assumption of it being random was only one 15-minute period. I'd proceed with caution. I'd rather have them do it over a course of several time periods through the day. But we're going to say that we're proceeding with caution. So certainly that all the conditions were met. Let me write some things down. All conditions met. We're going to use the one sample t-test, okay? Before we move on, let's make sure we do an alpha level, and let's call it 0.05. And now let's begin with our t-sample work. So let's go to our calculator. We have our data in stat edit, and now let's go to stat test. We're doing a t-test. So I realize it doesn't say one sample t-test, it's a t-test right there. That's what we're going to do. I'm going to go to my data, and I'm going to make sure that my data is correct. So my data is L1, got it. My null mean hypothesis is going to be 30, and I'm looking to know whether it's greater than 30. They want to know if they're speeding. So it's greater than 30. I'm going to hit calculate. This is what I'm going to write down, okay? I'm going to write down on my page the degrees of freedom. The degrees of freedom are going to be 23 minus 1, which is going to be 22. I'm also going to write down my t-score. My t-score here was 1.178, a little more than 1 standard deviation, and my p-value is a whopping 0.126. So now that we have this information, we're talking about phantoms. We just found, we did N, name the test. We did T, do the test. We did O, obtain the p-value. And now we're going to do make a decision. And our decision is going to be, because the p-value of 0.026 is greater than the alpha level of 0.05, we fail to reject the null hypothesis. And remember, just like with a proportion, the mu is what we're going to be using the alternative hypothesis wording to do this. So if you recall, the question was, does the mean speed of all cars exceed the posted speed limit? What we're going to say is there is no evidence that the mean speed of drivers on, remember, was Trip Hammer Road. Trip Hammer Road is above posted speed limit of 30 miles per hour. Okay. So we're talking about mean speeds now, and we're just reiterating what it's saying. There's no evidence that the mean speed of drivers is above the speed limit of 30 miles per hour. Period. Done. Move on. So let's do one from the book and see whether we can play around with that. Take a moment to read it. So what they're trying to do is they're trying to see whether a fleet of cars is obtaining at least 26 miles per gallon. Okay, so they want to know if it's at least 26 miles per gallon. Think about it this way. If it's getting more than 26 miles per hour, that's a good thing. We wanted to know, I'm sure, we're going to keep reading, but it's going to be less. Because if it's more than 26, great. That's wonderful. Great news. Move on. Just like if you told me I want to raise at least $200 to be able to go to to buy tickets to a concert. If you raise $250, great. We're looking to know whether you don't raise it. That's always the concern. So they're checking 50 company trips. That's going to be our N. This is our N. Let me make a note. This is our N. Here's our mu. Finding a mean, and the standard deviation is right here. Is this strong evidence that they have failed to obtain the true fuel economy goal? Sorry, this is not mu. I apologize. This is our mu. This is our y bar. Pardon me. I apologize. We're good. Is this strong evidence that they have failed to obtain their fuel economy goals? So we're at 25 miles per gallon. It should be 26, but it's close enough, right? Let's do some math and let's confirm it, okay? So we're going to go through phantoms. So our parameter is going to be, so this is P is parameter, not the proportion. The parameter is going to be cars miles per gallon. Okay, so our null hypothesis and alternative hypothesis, we're going to do mu equals 26, and we're looking whether mu is less than 26. Let's state our alpha level right now. Our alpha level is going to be 0.05. So now let's talk about our assumptions and conditions. Random. Let me write it so that we have room. Random. Car trips independent of each other. Less than 10% probably of all the trips. I mean, this is a fleet of cars, less than 10% of all trips. I would think that's going to be less than 10% of all the trips. And now let's talk about being large enough. The number is 50. So they're not telling us that anything about the data itself, but because n is greater than 40, right, we can use the normal model. Okay, great. So now let's go through then putting the data into our calculator. Because all the conditions were met, because conditions met, we can use the one sample t test. I need to let the dog out. Give me 1 second, guys. Pause. Go outside. Go ahead. Go find Daddy. Sorry about that. Okay, so let's go to our calculator and let's see what we're going to write down. So we're going to go to stat tests. We're going to go to a t-test. We're not doing data this time. We're doing stats. Enter. My mu is going to be 26. My X bar or Y bar was, forgive me, I don't remember the exact number, 0.25.02. And our standard deviation was 4.83. The number in the sample was 50. And we want to know if the mu is greater. We want to know if our sample was less than. So now we're going to do calculate. Okay, so we get a t-value of so let's write some things down here. Degrees of freedom is going to be 49, right? Because it's going to be 50 minus 1. My t-value is going to be negative 1.43. And my p-value is going to be 0.079. So what are we going to say now? We are going to say, because the p-value of 0.079 is greater than 0.01, we fail to reject the null hypothesis. We have no evidence that, and what are we trying to answer here? Let's say that they have failed to obtain their economic goals. They have failed to obtain their, what are they calling it? Fuel economy goals. Fuel econ goals. Just to make a point real quick, this p-value of 0.079, if I had chosen a alpha level of 0.1, we actually would have rejected the null hypothesis, that there was strong evidence that they failed to obtain their fuel economy goals. So this would be an example of picking the alpha level. You could pick 0.1, and you saying fail to reject, you saying reject would also be correct. So make sure that you are complete in all of your context of what you need to do. Let's move on. Remember that significance, being statistically significant, does not mean actually important or meaningful. It's a good idea to look at the confidence level as well as the and the confidence interval as well as the hypothesis test together to be able to think about whether, in fact, the meaning of the different numbers. They are from the same calculations. They go hand in hand. I would hope that one of the problems on the AP will be a hypothesis test confidence interval question. That's my feeling, hopefully, because then it'll kind of kill two birds with one stone, that you know how to do a hypothesis test and a confidence interval. That being said, let's talk a little bit about this. Remember, confidence intervals are two-sided by definition. So it's going to be C minus 1. That's when we pick our alpha level of 0.05. But if you have a one-sided hypothesis test, just make sure that you are dividing by 2. If the hypothesis test is one-sided, like the one we just saw with the fuel economy and even with the Trip-Hammer Road question, you would want to make sure that you're doing your alpha level of, if you wanted to compare to the confidence interval, you want to take it and divide it by 2. Okay, so just kind of making sure. So and if the Trip-Hammer Road question, I believe we had done a 95% confidence interval first. This would have been on Friday, I think. We would have done actually a alpha level of 0.025, and certainly that would have been also going to be failing to reject. Okay. So the last thing I want to talk about today is sample size. When we are finding what size sample size to use if we want to have a margin of error of a particular number, numbers of like 3 and 4 are normally nice when we're talking about doing polling for presidential elections. I've noticed a lot of them are 3, 4, 5 tops. So the issue is that the T critical value uses n in finding the degrees of freedom. So if we're looking for n, how are we going to be able to use the degrees of freedom for that? And the answer is we're actually going to tweak the formula a little bit and first use a z critical value. So to find the mean number of samples to get the right margin of error, you actually have to do 2 steps. So let me walk you through an example, and so that way you know how to do it. It's a little bit tricky only because you have to do it in 2 steps. So let's go through this example. They want to see whether the downloads are how many download samples should we do in order to find degrees of the margin of error to be 8 minutes. So if we're doing means, which is what we're doing right now, we're doing mean download time. That's a clue. So we certainly would want to do to find the margin of error. The margin of error would be t critical value n minus 1 times s over square root of n. But remember, we don't know n, so we can't use the t critical value. So I'm first going to start with the z critical value times n square root under the square root. So here we go. So let's do this here. So I'm looking for 8. So I'm going to do 8 equals at a 95% confidence level, we're doing 1.96 as our critical value times, it said the standard deviation was 10 over the square root of n. Remember, the 8 and the square root of n can flip-flop, right? These two can flip-flop. So I'm going to do my math, and I know we can do 1.96 times 10. Obviously, I could have just done it all the math, but let me just show you everything so you're all good. Divided by 8, enter. And then we want to square it to take the n by itself, okay? So we get 6.0025. So n equals 6.0025. If I wanted, so I'm going to round it to 6, okay? Fine. So then I'm looking for degrees of freedom of 5. So I'm going to now go back to my t critical value. I'm going to use 6 minus 1, which is 5, times my s over square root of n. I'm still looking for 8. So now let's go to our calculator and let's find what our t critical value would be. So I'm going to do second distribution. I'm going to go to inverse t. I'm still looking for a 95%, but in this case, I'm looking for, remember, it's going to be, each side is 0.025, which would be equal to 95% confidence interval. So I'm going to do a 0.975. This is really a tricky thing, and hopefully it's starting to stick a little more, but I would do 0.975. My degrees of freedom will be 5, and I'm going to hit paste. And it's going to tell me that my critical value for the t is going to be 2.57. So I'm going to replace this with 2.57 times 10 over square root of n, and that's going to equal 8. When I do my math, so again, I'm going to do all the math just so everyone knows, because usually it's not going to be nice and easy. 10 times 10 divided by 8, because I switched the square root of n and the 8 because I using multiplication, and I get 3.2195, 2125, sorry, and I'm going to square it, and I'm left with 10.3. So my n, the number should be 10. Okay. If you want, maybe you want to write that n equals 10.3, and then they're going to say, therefore, the number in my sample should be 10 downloads. Okay. That was it for me today. So tomorrow I will give you a few questions to do for homework, and that's it. You guys have a wonderful day now. Bye.